It's question show time. Your questions, my answers. As always, wherever you are across my channel, if a question pops into your brain, just write it down. I'll gather them up and I will answer them here. Now, I am doing this show on Monday, March 22nd, 2021. And so whenever you're watching this, it was live for when I did it. And so if my answers are out of date, if the aliens invade, if Starship makes it to orbit, then perhaps some of the things I say will be a little out of date. So, just understand that. Micro Chandran. Hey, Fraser, what type of stars are visible to the naked eye in the night sky? That is a great question. I always say that's a great question, but that's a great question because we're actually seeing a very specific kind of star in the night sky with the unaided eye. So the most common stars in the universe, of course, are the red dwarf stars, and they are everywhere, and they are dim, but you can't see them. Like the closest red dwarf star to us, Proxima Centauri, you can't see without a telescope. And the rest of them are all not possible to be seen. So the stars that we're really seeing are the bright stars. Stars as bright as the sun, or actually like much brighter. Stars that are multiple times the mass of the sun, stars that are dozens of times the mass of the sun. And so when you look out into the sky and you're seeing all these stars, you're actually seeing extremely massive stars that are often very far away from us. So when you look at, say, Betelgeuse, which is one of the brightest stars in the sky, we know that it is like somewhere between 500 and 600 light years away. And while Alpha Centauri, which is a very bright star in the sky, is only, say, 4.5 light years away. And so the vast majority of those stars that you see, they're all actually really hot stars, which is, or giant stars. And so we're actually seeing a very warped version of how the universe truly is. Tyler Vandeven. How long did it take for the solar winds of the Carrington event to reach Earth? Would you be able to reduce the damage by having a planned shutdown of all the power grids until it passed? I know they do that with satellites when the sun has a solar flare and it keeps them safe. So when you have a severe solar storm that impacts life here on Earth, you get this chain of events. So you get this really, really powerful flare on the surface of the sun. And then it takes about just over 8 minutes and 20 seconds for the photons to go from the sun to reach the Earth. And so that's where we get our first warning that something big has happened on the sun. After that, you get some of the faster particles arriving quite rapidly after the solar flare comes by. So the first thing you get solar energetic particles, and they can come within 20 minutes to several hours. And it just depends on the strength of the flare. Then, and this is sort of the big one, is you get the bulk plasma that was ejected. And that is just all of that material, that hydrogen that's blasted off the surface of the sun. And that takes anywhere between like a day and 3 days to arrive. Again, it sort of depends on the velocity. It depends on the force that it's been thrown off of the sun. And that's the stuff that interacts with the magnetic field here on Earth and can cause damage to our electronics. So one of the big goals of space weather is to actually be able to tie together to see, okay, we saw a flare of this power on the sun. It was pointed in this direction. And then we know that this regime of particles is going to arrive at this time. And then those particles are going to arrive at that time. And then you're exactly right. Try to be able to disconnect pieces of the grid, shut down really special parts of satellites, and try to be able to minimize the damage that we're going to experience here on Earth. And that's one of the main goals of all of the various space observing that's happening right now with all the different satellites. And the more we learn, the safer we can be into the future. Raphael Dominichini, are you going to watch the TV series Foundation based on the books of Isaac Asimov? Absolutely. I would say the Foundation books are some of my favorite science fiction books ever. Although, recently rereading them, I reread the Foundation books about 2 years ago, and they didn't really hold up. They're great, and when I first read them, they blew my mind. But this time around, maybe I'm a little more jaded. Maybe the ideas have, it's kind of like watching The Seven Samurai, and you're like, oh, I've seen these ideas. Come on. a bunch of ragtag group of heroes forming to defend a town, and the number is 7, yawn. But of course, the Seven Samurai, defined the genre, and so maybe Foundation did the same thing. But yeah, am I going to watch the show? Of course. Like I would watch. I watch almost every science fiction series that comes out. I'll give them a shot. But people always want to know if I'm excited about stuff. And I'm almost never excited about upcoming shows. I watch them. If they're good, awesome. If they suck, that's too bad. But I never get my hopes up. Like everything just has to stand on its own 2 feet. Mitch Harpino. If I robbed a bank on Mars, how would I be prosecuted? When we think about the future of humanity in space, and as we live on other worlds, we're going to have to start thinking about space law. And the reality is that there already is a certain amount of work that's being done in space law. And the background law that everything has to fall under is called the Outer Space Treaty. And this was signed like decades ago by pretty much every spacefaring nation on the planet. And really the main goal was to say space is a wilderness, kind of like Antarctica. So nobody can own it. And nobody definitely can ever put nuclear weapons in space. Like that's just like rule number 1, no weapons of mass destruction go to space ever. But they didn't put a lot of energy into thinking about just like ownership of things like that. And so as the rules are defined right now, if you build a base on Mars, if you build a bank on Mars, and that bank is actually a research station by your country. So it would be I'm not sure where you live. Let's say it's an American research station. And anybody is allowed to come and use the resources of your bank, and you can't stop them. So it's actually impossible to rob a bank on Mars because you have to essentially provide shelter. You have to provide all of the benefits of your station to anybody who shows up because it's in neutral territory. So it's actually currently impossible to rob a bank. But you would expect at some point people are going to figure out like a law about this. And the way it's going to work is essentially if it's an American bank that's on Mars, you're going to be following under American law. Now the challenge will be for them to actually prosecute you, to find you on Mars and bring you to jail. But in the future, of course, if and when Mars ever secedes from the Earth and becomes its own nation, then you'll fall under Mars law. And I'm sure they have all kinds of rules for that. But until that actually happens, you as a citizen of whatever country you come from will be tried under the rules of, it's sort of in exactly the same way as if you, rob a ship in the middle of the ocean or rob an Antarctic research station. So, yeah. Mikhail Banikov, what do you think will be a braking solution for future spaceships that will travel some percentage of the speed of light? Slowing down with thrust appears to be way too wasteful. So when we try to send a spacecraft to some other star system in the future, the best idea that's been thought of so far is to use some kind of laser system and a laser sail to accelerate a spacecraft to a high velocity, and then it will coast the distance to reach the other star system. And the challenge, of course, is that once you accelerate the spacecraft to a very high speed, but you don't have some way to actually slow it down again on the other side. Like you're not going to have some laser system that's there to catch your spacecraft and be able to slow it back down again. And so what's going to happen is the spaceship is just going to fly right through the star system, take a bunch of pictures, send some pictures home, and that's that. So what can be done about that? And there's a couple of ideas. You need a system that isn't going to use propellant, because if you're already going, say, 10, 20% the speed of light, there's not going to be some easy way for you to be able to decelerate yourself again once you reach the other stars. Like if you can't accelerate yourself to 20% the speed of light, you can't decelerate yourself to 20% the speed of light. It's going to be impossible. So you're going to need some other system to be able to do that. And the best idea that I've seen so far is that you essentially extend a magnetic sail out from your spacecraft. That's sort of like a solar sail. And then what it does is it interacts with the interstellar medium that you're plowing through with your spaceship. And each individual particle that you interact with this mag sail will slow it down a tiny little bit. And so you'll be able to bring yourself down from, say, 20% the speed of light down to, regular speed. And then you will need some kind of propulsion, whether it's like some kind of ion engine or something like that, to be able to slow yourself down to the point that you're actually able to go into orbit. So that's the best idea that I've ever heard. Otherwise, it's like if you can get yourself up to speed, then you can have a way that you can bring yourself back down from that speed. And so that you're going to need, if you can have a fusion engine that can get you up to 20% the speed of light, then a different fusion engine will bring you down to 20% the speed of light. Yeah, man. Can you put to rest all the theories that are spreading around the internet about catastrophes and crap, please? I have been trying to do that for 22 years now. And it hasn't taken yet. So, I'm doing everything that I can, by being just like, I'm just going to keep talking the science. I'm going to try to just outlive all of the nonsense conspiracy theory that goes on. It'll never go away. It's impossible to make it go away. We've been like battling, give you an example, like Planet X, right? This idea of Planet X, that there's going to be some mysterious planet that's going to be passing through the inner solar system. It's going to flip the Earth's poles and usher in the age of Aquarius or something like that. That was running around the internet when I started Universe Today in 1999. Like it was earlier than me. And yet me, Phil Plait, the Skeptic's Guide to the Universe, like all of these people have been battling these conspiracy theories. And YouTube just put that on steroids. Like YouTube gave people with even a passing interest in just space a way to go down the space conspiracy, flat Earth, Planet X rabbit hole, and has only recently been able to sort of shut off the fire hose. They haven't directed it towards science. I'm not sure where it's going now, QAnon or something like that. But they have not. But at least they're not driving people into conspiracy, into waiting arms of conspiracy theory. So all I can do is just talk about science. And if people show up and they like science and they're into it, then they will enjoy the channel. And if they've got preconceived notions about various conspiracy theories that have been put into their brain, then there's no way to really talk them out of it. And I actually don't think, like when I think about a person who is into Planet X, for example, I think they're more interested in, or like UFO abduction. I'll use UFO abduction. I think they're more into the idea that they know something that the mainstream doesn't know. That it's more about being part of the in crowd than it is about genuinely being interested in the answer to these questions. Because there's plenty of evidence. There's plenty of people who have dedicated their lives searching for evidence, who have other opinions. And yet, obviously people don't listen to it. So no, I can't. I can't do anything about it. All I can do is I can just outlive them. I was here for 2012. Do you remember 2012? We were posting dozens of articles about what was not going to happen in 2012. And that's like 8 years ago. Nothing happened as predicted. And so nothing is going to happen into the future as predicted until something does. But that's like, a billion years from now. So don't worry about it. Jonathan Allen. My child is 7. Do you think that he will see a human come back from an interstellar trip in his lifetime? Interstellar? No. Interplanetary? Sure. Yeah, I think that your child will see people go to Mars and come back home safely. In his lifetime, there will be a tremendous amount of people flying between various places within the solar system. Between other stars? No. Like if you just literally just take the math of the amount of energy that has been used by humanity over the history of humanity, you go back 1,000,000 years, even 100,000 years, there's a smooth curve of how much energy used. It's an exponential curve of how much energy humanity is able to muster. And that number just keeps going up. And so we can expect that that number will keep going up into the future. And at the same time, you look at the amount of energy it will take. We talked about this earlier in the show about trying to send a spacecraft to another star system. You need to generate enormous amounts of energy. Those cross in about 700 years from now. So the amount of energy that humanity is able to produce crosses with the amount of energy it takes to fly to a star system without bankrupting humanity. It's about 700 years, 800 years is the prediction. And so now maybe your child's going to live 700 or 800 years with modern medicine and robot body. I mean, of course, I'm going to live 800 years as I may go through a couple of robot bodies, but realistically, in a time that you could be patient for, no. But interplanetary, absolutely. Really, the good stuff is going to be happening in about 150 years, 200 years from now. That's when the solar system will look dramatically different. More questions in a second, but first I'd like to thank our patrons: Rob Bennett, Tony Lazar, Chris Clow, Joe Torres, Brad Bryant, Ron Thorson, and the rest of our 847 patrons for their generous support. Want our videos early with no ads? Join our community at patreon.com/universetoday. Sean Marson. Hi, Fraser. I would love to hear your thoughts on the practical use of an Earth-Mars cycler transfer orbit. Is it worth the risk? Thanks. Now, I'm not exactly sure what you're talking about, but essentially you're just talking about like a ferry system that's going back and forth from Earth to Mars, interacting with the two planets gravitationally so that you can essentially transfer astronauts from Earth to Mars, from Mars back to Earth. I think Buzz Aldrin was a big proponent of this idea. And I think the idea is great in theory, that you've got this permanent way of getting people to and from planet Mars. It's this idea, and I talk about this a lot, this idea of infrastructure, that our existence in space becomes easier and easier once we have more infrastructure. Right now, every mission that we try to do to send humans out into space, we have to carry all of the infrastructure with us. We have to launch the spacecraft from Earth with a capsule on top that contains all of the supplies to get the humans to, say, the moon and back. What if we've got some orbital fuel depot that a Starship can fly up to, dock, transfer fuel, and now it can go way farther? Infrastructure. What if we have one of these orbital fuel depots out at Mars, where spaceships can go and dock there and transfer fuel and fly to other places in the solar system? Infrastructure. And what if we have some regular spacecraft that is constantly making the journey back and forth from Earth to Mars, carrying people in both directions? That would be amazing. You could totally up-armor it. It would be a lot safer from solar radiation. It would be sort of like a very comfortable way. You could still do science. It'd be like the space station, but you are making this journey to and from Earth to Mars. So I think just in general, and even, we see that here on Earth. You build an internet, you get value. You build a interstate highway system or interprovincial highway system, and you get value from it. And so always there's huge value in building infrastructure in whichever way that works. Fuel depots in space, space stations that are positioned at Lagrange points, which can act as gateways to other places in the solar system. All of that stuff will help sort of make our lives, our exploration of the solar system easier and easier and easier over time. 6 Bob Ohms. Fraser, since the GMT mirrors just fit inside a Starship, should we send some to the moon and build a lunar GMT? So I did a video a couple of years ago, maybe at this point, about the idea for building the overwhelmingly large telescope, but building it on the moon. So building a 100-meter telescope, but instead of it being on Earth, you build it on the moon, where the gravity is 1/6, and so you can build it with 1/6 the support, and so it's actually like the perfect place to build a telescope that big. Or you could scale it up and you could build one that has 6 times the mass and on the moon. And if you were actually able to build a telescope that big on the moon, it would be directly imaging planets. You would be seeing right out to the edge of the observable universe. It would be the most wondrous tool. But even trying to go and set up on the moon is a bit of a pain, and you still are dealing with gravity. Why go to the moon when you could just be in space? Then you could build a space telescope of any size. You could build a telescope that is 1 kilometer across, and there's no gravity. So it's just about building all of the trusses to make sure that the mirrors stay in the right shape. But you don't have to worry about supporting the weight of the telescope. So I think that if you want to build a big telescope, just space itself is going to be the place that's going to make the most sense. We're going to move from large space telescopes being launched in a spacecraft one time to this future where we build interferometers in space, multiple telescopes flying in formation as big as we can possibly make them. And then over time, you just add more and more telescopes to this fleet of spacecraft, and your telescope just gets bigger and bigger and bigger. So maybe the biggest possible telescope that you could load up into a Starship is like, I don't know, 20, 30 meters across, folds out, maybe, or maybe you go down the route of actual assembly or even manufacturing of the telescope portions in space itself. And then you could build one that's kilometers across where you're 3D printing trusses and then you're laying down your telescope material on top of it. Yeah, you could have a telescope that's 10 kilometers across. It's just a matter of launching enough spaceships. So we don't know what the future holds for telescopes. We do know they're going to be big. And a lot of it is just, it's going to be the next phase of telescope construction is us building giant telescopes, interferometers in space. LUVOIR will probably be like, if it ever gets built, it'll be like the last telescope built the old way. And all the future telescopes will be built kind of like the International Space Station, assembled in space in parts into bigger and bigger observatories. And then you just put a second telescope that flies in formation, and now you've got an interferometer that's acting like the distance of the two telescopes. So, yeah, it's gonna be great. Enzo, are there any pictures or videos that accurately depict what it looks like to look at the vastness of space from space with the human eye? I know the exposure of cameras is a difficult factor. It would be very easy to depict what it would look like to see space from space. If you were an astronaut on board the International Space Station, and I've talked to them about this, what they say is that the stars themselves are much brighter. That, in fact, the stars are so bright that you have a hard time telling them apart. And so here on Earth, where we've got light pollution, we've got the atmosphere, clouds, things like that, we're familiar with constellations. But the astronauts I've talked to, once you get up into space, you can't find your constellations, even though you know them. Like, you could have been an amateur astronomer all your life, and if you go to space, you have a really hard time recognizing, oh, there's Orion, because all of the stars that are in the constellation are all really bright. All of the stars everywhere are really bright, and you don't have a lot of time as you're sort of whipping around the Earth to be able to sort of get your bearings. And the astronaut I was talking to, he found that very disorienting because he was expecting, as an amateur astronomer, to go to space and go, okay, it's going to be just like I did on Earth, but now I've got, like I'm a human Hubble Space Telescope. This is going to be the best. And he said, actually, it was really tough. You could see the moon, you could see some of the planets, you would recognize those, but the actual stars, it was rough. Once you're actually like thinking about some of the other things like nebulae, galaxies, things like that, they actually don't look very good at all, even in space, because you do, as you mentioned in your question, you need the long exposure from a camera to show off the fainter stuff in these objects. And so you could be standing right beside, in your spacecraft, right beside the Orion Nebula, and you wouldn't really see it. Even if you got close, you're right on the edge of the Orion Nebula, well then, as you get closer, the nebula spreads out, and so the light is spread out over a much larger area, And so it wouldn't look very good. But there are a few objects that would look pretty cool. I mean, if you could get close to a black hole and see the accretion disk, or say a globular cluster, you get closer to one of those so that it filled the sky with a ball of stars, that would be pretty great. But nebulae, galaxies, there's pretty much no place you could go that would make them look better with the unaided eye. Once you take a telescope, then absolutely, telescope, camera, get them very close, it's going to look great. Basket of puppies. If aliens live in the fourth dimension, we wouldn't see them, right? No, we could see aliens that lived in the fourth dimension. We just wouldn't be able to see the way they actually looked. We would only be able to see a three-dimensional projection of their four-dimensional nature. And you could do this, you could think about, say, what does a cube look like seen from two dimensions? You're essentially just taking slices through a cube. And so you see different shapes. If the cube is face on, then you're going to see a square. And so if a two-dimensional creature would experience a cube as it passed through their plane in different shapes. Maybe when the cube first started, if it was coming in corner side, it would look like maybe a triangle. And they'd be like, what's this weird triangle? And then the triangle would get bigger and bigger. Or if it came through sideways, then they would see a square, or maybe they would see a rectangle or a parallelogram or something like that. And they would experience a cube. A circle passing through a sphere passing through a plane would be a circle. It would start as a small circle and get a bigger circle. And so you can kind of imagine different three-dimensional objects as they pass through a two-dimensional plane. A creature that lived in two dimensions would be able to experience different shapes based on the angle of the three-dimensional objects that pass through the plane. And so if you scaled up everything one more notch, you would have four-dimensional creatures, four-dimensional structures passing through our three-dimensional universe, and we would be able to see a projection of it. We wouldn't be able to get its actual true four-dimensional nature, but we would be able to see something, and which is kind of cool. Dimensions, one of the things that's neat about dimensions is like the math explains everything that you would want to know about it, but you can't actually experience it with your own senses. You can calculate what things will do, what a four-dimensional cube looks like, or how it behaves, and yet you couldn't actually look at one without going crazy. So, or even look at one. So it's a neat idea. And of course, this is one of the ideas that if we, one of the possibilities when you sort of think about like, how could you fly through the universe, a finite universe, and return to your starting point, even though it's three dimensions? Well, if you're a four-dimensional creature, it's easy to understand. They're surprised that we don't get it because we're trapped in three dimensions. We can't comprehend how that would work. And yet it's a perfectly reasonable possibility to explain why the universe is flat and how you could, and if it's finite and flat, then yeah, if you went in any one direction, you would return to your starting point after a finite amount of time. Walid Damuni. If we collect the solar ejecta, will we find regular atoms in it? What elements are there and what ratios do they exist in? The solar wind is material that is streaming off of the sun. The sun is made of mostly hydrogen and helium, and the solar wind contains atoms of hydrogen that are being blasted off the sun. Protons, really, when you think about it. Because it's hydrogen, but it's just one proton. And then you've also got electrons and plasma, various levels of ionization. But it's just regular elements, just hydrogen, helium coming from the sun, and and hydrogen, helium, and electrons coming from the sun. Larry Beckham, did you know the Starship BFR stack to orbit cannot launch from land? Too loud. Must launch from a rig in the Gulf of Mexico. Is that true? I'm not sure. Too loud? Too loud for what? Too loud for human beings nearby to handle? Too loud for the acoustics not to shake the rocket to pieces? Definitely from just like being a good neighbor. Yeah, the Starship is going to be super loud. I know that SpaceX has purchased a couple of old oil rigs called Phobos and Deimos, and they're going to be trying to eventually launch these things from these rigs off the coast because they are going to be so loud and also kind of dangerous. We've already seen a couple of Starships explode. Super Heavy is going to be this enormous stack, this bomb And so it makes sense to try and launch this thing away from just land, humanity, everything. You know, when you think about the practical realities of having these things take off and fly around the earth, and, you know, like, I know one of the ideas is that Starship could eventually be a point-to-point system for getting human beings around the planet, which I don't think that'll happen. Like, it's just like, I think it's still going to be too expensive compared to just taking an airplane. Like, being able to cross the planet in 15 hours is fine. That's fast, as opposed to being able to do it in 45 minutes for $1 million, right? But maybe, you know, there'll be some times where you need to send a shipment to the other side of the earth. But I know, you know, they've already bought the rigs, and I know they're going to be converting them, and they're going to be launching them off of these rigs. So I'm sure that's the long-term plan once they've settled on all of the challenges. It's going to be crazy. Again, the mind just sort of boggles at the scale of Starship and Super Heavy, and the possibility of entering an era of fully reusable two-stage rockets where the launch costs are cheaper than any rocket system that's ever been built. It's, again, just mind-blowing. Horizon Brave. So we know stars and planets formed X amounts of years after the beginning of the universe, but are there still stars forming right now? I don't mean when we see the light, but actually. Sure, yeah, there are stars forming across the universe right now. Now, when we look out into space from our position here in the Milky Way, we are looking backwards in time. And so as we look farther and farther, I mean, we see Andromeda as it looked 2.5 million years ago. When we see giant galaxy clusters, they could be 100 million years ago. And some of the farthest galaxies we've ever been able to see, we're seeing them as they looked 500 million years after the Big Bang. And if we could look at them today, they would look similar to the Milky Way. But we're seeing them at an age when they were a lot younger. And we know that the majority of star formation was happening when the universe was just a couple of billion years old. That was the time when there was like the most amount of raw hydrogen fuel that was available to produce stars. And so the bursts of star formation, the universe party happened just a couple of billion years after the Big Bang. And now we're already on this slow decline. But there are still stars forming in the Milky Way every year. But there are places where there are galaxies where they are forming stars 10 times as fast as the Milky Way. And in the future, when the Milky Way and Andromeda merge with each other, we will go through another period of rapid star formation. You know, there's that saying, you know, that when you look into space and you wish upon a star, that star is actually long dead, just like your dreams. And that's not true. Every star that you're wishing upon is only just a few hundred light years away. All of those stars are still there. All of the stars, I mean, the farthest we could see in the Milky Way is still maybe 30,000 light years away, 30,000 years. So the various parts of the Milky Way that we're seeing, they're not that long ago. And there's plenty of stars still forming. And so when you see new stars forming in the Orion Nebula, they're forming like effectively right now. Yeah, maybe 1,000 years ago, but essentially now. I mean, they're going to continue to form for a few million years, explode as supernovae. The cluster will fall apart and the stars will join the rest of the Milky Way. But yeah, plenty of stars still forming all over the place. Hiroshi loves you. Hey, Fraser, what are your thoughts about landing on Mercury? Yes, we should absolutely land on Mercury. Why is nobody doing this? Why are there no plans for a lander for Mercury? Mercury is actually a really fascinating world, and it's got a lot more going for it than, when we imagine Mercury, we just imagine someone just took some metal and rock and just baked them in the oven, and it's just this awful place that's brutally hot. But the reality, of course, is that Mercury is just like the moon. Half of Mercury is in scorching sunlight, and half of Mercury is in eternal shadow as the planet turns very slowly. So it's not eternal shadow. But anyway, at any point, half of Mercury is in sunlight and half of Mercury is in shadow. Half of it is super high temperature. Half of it is extremely cold. And Mercury has permanently shadowed craters at its poles, just like the moon does. And it's possible that there are reserves of water ice in the poles of Mercury, just like there are reserves on the moon. We're all excited about water on the moon. There could be water on Mercury. And Mercury is made of metal and rock, a very fascinating world that's very close to the sun and has a lot of really interesting secrets to share. And I would love to see a spacecraft, a rover, a lander, something to go to Mercury. There's plenty of power. It's so close to the sun that the solar panels will get a tremendous amount of energy, and you can just sort of dip in and out of the sunlight and the shadows and be able to explore on Mercury. So yeah, I would love to see, and I'm sure somebody has proposed an idea for a lander rover system that would go to Mercury. I'll look into it because I think it's great. Mercury is it's a forgotten world, but it's fascinating, and we should absolutely go back. Way easier to get down to the surface than, say, Venus. And Mars is cold and not hard to use energy that far out. But Mercury is well worth exploring. And there's some really interesting terrain that's been seen on Mercury. Yeah, Mercury for the win. Now I'm all about Mercury. Now I'm stoked on Mercury. Sorry, Ganymede. Take a step back. Mercury is my favorite place now. Yeah. All right. If you want a single comprehensive resource for space news, you're going to want to subscribe to my weekly email newsletter. Every Friday, I send out a magazine of space news with dozens of stories, pictures, brief highlights, and links you can find out more. Go to universetoday.com/newsletter to sign up. It's totally free. And did you know that all of my videos are also available in a handy audio podcast format so that you can have the latest episodes as well as special bonus material like interviews with me show up on your audio device? Go to universetoday.com/audio or search for Universe Today on iTunes, Spotify, or wherever you get your podcasts. And I'll put a link in the show notes. Thank you to everyone watching here and on Twitch and everyone who asked a question. Now, if you want to ask a question for an upcoming show, you can post it in the YouTube comments or in Patreon, or you can join me live on my YouTube channel every Monday at 5 p.m. Pacific time. Thanks to all the moderators, and a special thanks, as always, to Chad Weber and Nancy Graziano.